to continue to write the equations in slope-intercept form. This time we're going to be given a situation. All right, and then we're also going to look at the multiple representations, a graph, table, situation, and the equation, all representing the same information. Okay, so we're going to kind of bring it all together as well. So, number one, a line has a slope of -9 and a y-intercept of 2. What is the equation of the line in slope-intercept form? What's our slope? Good. And our y-intercept is? 2. So these aren't like real situations, they're just trying to get you used to substituting the numbers, okay? Number 2, a line has a slope of 4.5 and a y-intercept of -10. How can we write that in slope-intercept form? Good. Plus -10 or minus. Either one is fine. Okay, either one is fine. Number 3, a line has a slope of -5 and passes through the origin. What is the equation of the line in slope-intercept form? Is that it?
Yeah.
Good. So when it passes through the origin, your x is 0, your y is 0, right? Alright, Carlin wants to buy some fish to keep in her room. At a local pet store, customers can pay $12.50 for a fish tank and $26 for each fish they purchase. So what is the slope of this situation? Slope is what? Right here? What operation is this? Multiplication. Anything that we're multiplying in this situation? The number of fish was what? Oh, good. 20 cents for each fish. Right? So that's for each fish. So this is cost per fish, right? Are we good with that? So that would be times x, and x represents per fish, right? What is the y-intercept? Good. $12.50. Why is that the y-intercept? Think about what y-intercept means. And why would $12.50 be the y-intercept? It's your initial value.
Because that's the price of the start at.
Okay, so it is cost of tank, right? Can you just buy the tank and walk out?
No.
Yes, you can.
Yes. Oh,
Yeah, that's just the cost without fish. If 0 fish are purchased, right? Yeah. And then parents can buy the fish tank, bring it home, and then they can bring the kids back, and you get to pick fish, right? Okay. Write an equation to represent the situation. So our equation would be what?
2.
2. Good. 2 times x plus 12.5. Are we good with that?
yeah.
All right. So with your table, I want you to write the equation for each situation for 8, 9, and 10, and we'll have 3 volunteers share.
Danny is diving for rings at the bottom of the pool and is 8.7 feet below the surface of the water. He grabs a ring and ascends 1.3 feet per second. Write an equation to represent the relationship between x, the number of seconds, and y, the number of feet below the surface of the water. Good. Y equals 1.3x minus 8.7. Let's give them one big clap. 1, 2, 3. Clarify anything on that one. We're good? Awesome. Number 9. Do we have a volunteer? All right, go for it. Marietta is saving up to buy a new car. So far, she has $12,350 in her savings account. She plans to save $500 each month. Write an equation. Good. Y equals 500x plus 12,350. One big clap. 1, 2, 3. Questions? All right. Do we have a volunteer for number 10? All right, go for it. A tree planted in Jake's front yard is 5 1/4 feet tall, and Jake is told that the tree should grow about 1/5 inch each month. Let X represent the number of months and Y represent the height of the tree. Write the equation in slope-intercept form. We had one similar like this yesterday. Good. Y equals 1/5 X plus 5 1/4. Good. One big clap. 1, 2, 3. Questions? Clarify anything? All right. Turn it to the next page. So now we're going to look at multiple representations to represent a situation. Okay, so there's multiple ways to represent the same information. Okay, so we're going to practice representing linear relationships in multiple ways with the following example, and we're given a situation. So we're going to use the representations given to help fill in these other parts, and then we do have questions according to what we. So our situation is a baby giraffe measures 6 feet tall when it is born. When it grows an average of 1/2 foot each month. Okay? And then you can start really anywhere, but from situation to equation, let's do that. What could our equation be in slope-intercept form?
Y equals
Good. We're good? Good. All right. So how can we create and fill in our table? So we have months that represent our X, right? 1/2 foot each month, right? And then we get the height in feet for each month, our Y. So how could we determine at 0 months, what could our process be? What math?
6.
How did you get 6? Okay, when it's born, that was given, right? What math is our process though?
1/2.
Huh? 1/2 what? What's our equation? What are we going to substitute in X for? 0. So that gives us 0. Then plus 6 gives us 6, right? So this is your equation, right? Your process, right? So after 1 month, okay, 2 months, 7, because it's 1/2 foot, right, each month. And then 3 months, 4 months, 5, and 6 months. Good. We're good with that? Okay. Now we have ordered pairs, right? 0, 6, 1, 6.5, 2, 7, right? So with those ordered pairs, can we create a graph to represent this situation? Absolutely. Okay. And so let's label what represents our x-axis? Good, months. So we can label this as months. And we're going to start with 0 here. And I'm just going to label 2, 4, 6, 8, and 10 because I see that we go all the way up to 9 feet. Or actually 6, right? For x. And then what's going to represent our y-axis? Height. And height is measured in feet. So I'm going to put feet in first. And then we can label that, again, we can just do 2, 4, 6, 8. 2, 4, 6, 8, 10. All right, and we can label when the giraffe is born, 6 feet tall, right? We can plot that point. At 1 month, 6.5, right? 2 months, 7. Oh, yes. 3 months, 7.5. 4 months, 8. 5 months, 8.5. 6 months, 9. We're good with that? Draw a straight line as possible. There we go. So we've represented this 4 different ways. They all represent the same information. We're good? All right, let's see if we can answer some questions. Explain how you found ordered pairs to create your graph. What did we do? Explain how you found ordered pairs. How do we find our ordered pairs? Through the table. What do we do with the table? Explain how you found ordered pairs. How do we find the ordered pairs? Good. We used the equation. What do we use the equation? What did we do? Use the equation to input our x value, right? Which was represented month. Okay, and that gave us what? We input, what's it going to give us? Our output, right? Our y value gave us our y value, which is our output. What is the slope of the graph? Which representation is easy to see that one? The equation, right? So what's our slope? Good, 0.5. What does that mean? Good. The rate the giraffe grows per month, right? Half a foot per month, right? What is the y-intercept? That's easier to see in an equation, table, and a graph, right?
Yes.
So what's our y-intercept?
6.
Good. And what does 6 mean? Good. The beginning or the starting height, whichever one, initial height of the giraffe. Right? We all have a y-intercept, whatever our starting height was, 19 inches. Number 4, what does the ordered pair 9, 10.5 represent in the context of the situation? What our x value represents what? Months. So we're at 9 months, and 10.5 is feet. So what's that mean? Height in feet. Good. At 9 months, the giraffe would be 10.5 feet tall in height, right? Wow. It's pretty tall. All right. If the giraffe is 12 feet tall, how many months old is it? So we're given 12 feet tall. 12 feet tall represents what? X or Y value? That's your Y value. Okay? Good. How can we figure that out? Which representation can help us? The table. Anything else? The equation. Can we substitute in 12 for what? What do we substitute 12 and 4? Which value? I thought y'all said it was the y value. What's 12 feet represents what value? X or Y? Y. Good. Substitute it there. Is that okay? Absolutely. It's a two-step equation, right? So we could do what? Subtract 6 on both sides? 6 equals 1/2 x. And then what do we do to both sides? Divide by 1/2. X equals 6 divided by 0.5 is 12 what? Good. X represents months. So the giraffe at 12 months old will probably be what? 12? Are we good? All right. So with your table, I want you to try these two situations, okay? So if you notice at the first one, you're given what? You're given the equation. The second situation, you're given what? A table of values. Okay, so I'll see where you're at in about 5 minutes and see how much more time you need.
Oops. How do we do here with a large piece of pizza costs $12 plus $1.50 for each topping? How do we do with that? Going backwards there. Okay. And then we got our ordered pairs in the table. 12, 13 and a half, 15, 16 and a half, 18, 19 and a half, 21. And then we use those ordered pairs to plot some of our points. How do we do with that? Clarify anything? All right. And this time we were given a table, so you probably went from table to the graph, right? Okay, and then from there, you probably wrote your equation, right? Y equals 1.2x, because our y-intercept was 0, right? And so at the patch, watermelons weigh 1.2 pounds per watermelon. Questions? Clarify anything there? Are we still checking? All right, so this is your practice. It's very similar to what we did. The first page is the multiple representations, then answering those questions. So you're gonna have more practice with that. And then the second page, you are matching the equation with the table and the graph, okay?